Welcome to space! Now, if someone were to tell you that the Earth is the centre of the universe, you'd probably think they're a little bit loopy. Although, it's only been the last couple of hundred years that it's actually been accepted that the Earth goes around the Sun. A few hundred years ago, if you were going to say in public that the Earth goes around the Sun, then you'd be put in jail. Now you can understand why people thought that the Earth isn't moving. It doesn't feel like we're moving. So why can't we feel it? I mean, the Earth is spinning at over 1,000 miles an hour and we're hurtling through space. Surely we'd feel that. No, it's because we don't feel speed. We feel acceleration. Acceleration is speeding up, slowing down, or changing direction. Hang on, we are changing direction. That's what moving in a circle is. So, we ask the question again, why aren't we feeling it? Well, the thing that matters is how quickly we're changing direction. And I'm going to show you how we're not actually changing direction very quickly. We can work out how quickly we're changing direction by calculating something called angular velocity. Angular velocity is written as the Greek letter omega, and it's worked out by doing 2 pi divided by t, where t is the time it takes to go in a circle. If we're going to work this out properly, we've got to work out the time in seconds. Now, if you imagine how long it takes to go around a roundabout, I'm sure you can do that in 30 seconds. If we plug the numbers in, we're going to do 2 pi divided by 30, which is approximately 0.2 radians per second. Radians per second probably doesn't mean a lot by itself, so we're going to compare that with what the angular velocity is for the Earth going around the Sun. So let's work that out in seconds. We've got 24 times 60 times 60 times 365, which is 31,536,000 seconds. Now, if you want to be pedantic, it would be 365 and a quarter, but we're only talking about approximate numbers. So let's plug that in. We end up getting 0.00000002 radians per second. Now, 0.2 divided by 0.000002 is 1 million. In other words, with a bit of maths, we've shown that you'd get 1 million times more dizzy just going around a roundabout than travelling around the Sun. I would love to give you a scaled example of what's going on. The only problem is I will need a screen that's at least 3 meters long, because even if Earth were the size of a pixel, then the distance between the Earth and the Sun would be over 3 meters. So it's going to have to be left up to your imagination. So how did we get from thinking that the Earth is the centre of the universe to being able to work out exactly where things are going to be in the sky? To being able to send things into space to land on Mars? Well, it's mostly thanks to these guys. There's Nicholas Copernicus, Galileo Galilei, Tycho Brahe, and Johannes Kepler. Someone that you might have heard of, Isaac Newton, he had something to do with it too. But let's concentrate on these first. Let's start with Nicolaus Copernicus. Copernicus was born in 1473. He he was actually educated for a career in the church, which is kind of ironic considering it was the church that ended up banning his book. Although, as part of his education, he got to learn about maths and astronomy. What did he like doing in his spare time then? He wasn't much of a party animal. In fact, he spent most of his spare time observing the skies. He also loved this idea of order. So the geocentric model, that's the one where the Earth's at the centre, didn't sit right with him. If you try to explain what's going on in the skies, it just got overly complicated. Have a look at all the drawings that they ended up making up. Those little circles are things called epicycles. It's really messy. There's got to be a simpler way. And a simpler way is just that the Earth is going around the Sun. Copernicus wasn't the first person to have the idea of the Earth going around the Sun, although he was the first person to put a logical explanation for it. He even wrote a little book. This little book was published but didn't have his name on it, and he just sent it around to some of his friends. The reason he didn't put his name on it is he would get into a lot of trouble with the church if he was going to suggest that the Earth wasn't the centre of the universe. Now, this little book was published in 1514, but it had some very important points on it. He had 7 axioms. These are the axioms. There is no one centre in the universe. The Earth's centre is not the centre of the universe. The centre of the universe is near the Sun. The distance from the Earth to the Sun is imperceptible compared with the distance to the stars. The rotation of the Earth accounts for the apparent daily rotation of the stars. The apparent annual cycle of movements of the Sun is caused by the Earth revolving around it. The apparent retrograde motion of the planets is caused by the motion of the Earth from which one observes. Now the last one is particularly interesting because the retrograde motion of the planets is the one that puzzled people for the longest time, and I'm going to go into that one in more detail in the next video. Now, as simple as these axioms are, it set the whole thing in motion. Although he was reluctant to share his ideas, and it wasn't until he was on his deathbed that he was convinced to publish it properly. So, thankfully, his ideas did not die with him. In fact, he had quite a following, the most notable of which was Galileo Galilei. We're going to have a look in the next video about how Galileo and Kepler and Brahe kept his ideas alive. We're also going to have a look at what this is all about.